very good evening to all of you. You are joining with us for the fourth session of Step to IoT, a webinar series on the Internet of Things organized by IET on campus, University of Peradeniya. Throughout this series, we have been talking about various aspects of the Internet of Things. This announcement is for those who are participating, who are interested in doing some IoT related projects, and those who are already involved in such projects. If you are interested in receiving guidance and advice for the from the guest speakers of this event, please fill the form we have provided now. Mr. Weragama and Mr. Udunuwara are more than happy to help you all out. Moving on to today's discussion, we are going to talk about IoT access technologies, software-defined networks for IoT, cloud and IoT. And also we are going to talk about security and privacy requirements and security frameworks for IoT. If you're joining us today for the very first time, let me introduce the guest speakers of this event, Mr. Anuradha Udunuwara and Mr. Rajiv Weragama. Engineer Anuradha Udunuwara is a senior enterprise solutions architect at Sri Lanka Telecom with more than 17 years of industry experience. He graduated from the Faculty of Engineering of University of Peradeniya with a bachelor's degree in electrical and electronics engineering. And he is the world's first MEF Network expert with many other related achievements. Moving on to Mr. Rajiv Weragama, he is a senior engineer at Sri Lanka Telecom with more than 12 years of industry experience. He has a bachelor's degree as well as a master's degree in electrical and electronics engineering. And he is currently pursuing a PhD on the Internet of Things at the University of Peradeniya. Both of these individuals are trainers, researchers, as well as well-known speakers at Commonwealth telecommunication organizations. Now, without any more delay, I would like to invite Mr. Weragama and Mr. Udunuwara to start today's session.
Thank you, Sri. I hope you can see my screen, right?
Yes, sir.
Okay. So, good evening to all of you. Today is the fourth day of Step to IoT webinar series. And so far we have learned the basics, the definition of IoT and architecture and some more aspects. So today in the first half an hour, we will discuss more on the IoT access technologies. First, let's look at the definition of an access technology. What comes into your mind when you see these two words, the access and technology? There are so many definitions, and as per the PC Mag, the access technologies are the methods for gaining access to a computer system or any type of network. Now, when you're doing your projects and when you're building some kind of an IoT device, one of the most crucial things to do at the beginning is the selection of an IoT technology. So there are billions of connected devices, including cars, buses, or any sort of vehicle, office buildings, factories, oil rigs, homes, and sometimes we may have to connect entire cities. Some of them are stationary and some are mobile. And some of these devices have IP addresses, but some don't have any sort of IP address. They use some other type of mechanisms. And some of these devices are always on and some are turned on intermittently. And some devices are clustered together and others are geographically dispersed. So the scenario is somewhat complex. So this diversity is driving a proliferation of access technologies to connect them. No longer limited to the traditional Ethernet, Wi-Fi, and the other cellular technologies we talked in last few weeks. The IoT deployments today also include satellite, Bluetooth, low power wide area networks, we call them LPWANs, and so many other new techniques. So, which technology suits for your device or your project depends on several factors. You have to answer 6 questions before selecting the most suitable access technology. First one is related to the devices. How many devices and which type of devices are we going to use in our network? The next question is, are these devices will be used as fixed devices or mobile? So that is related to the mobility aspect. The third question is, how much data is being transmitted or to be transmitted? That is related to the bandwidth aspect. And the next thing is whether the data is time sensitive or whether the latency will have any sort of impact on the data we collected. That is related to the time. And for the battery powered devices, what sort of battery life are we expecting? So if we cannot charge that device once it is deployed, if it needs to run for a longer period, then we have to think about that particular time period which it should run by its own battery. And finally, will there be any sort of cost constraint? That is the monetary aspect. Now let's see the network technologies which are used to provide IoT connectivity. We can divide the network technologies into 3 categories. First one is the standard wireless access. Examples are the Wi-Fi, 2G or 3G cellular networks, and also the 4G LTE, and now we are talking about the 5G networks as well. And the second one is the private long range, or we call them LoRa-based platforms, and Zigbee and sigfox type techniques. The third one is the mobile IoT technologies. The examples are the LTM, NB-IoT, GSM IoT. We'll see what are the meaning of these words in our next few slides. So there is no doubt that IoT is driving a lot of changes in connectivity. The rule that connected devices impose over the networking technologies is not the same as in our mobile phones. Today, we are in the middle of a technology change that we may not yet realize. As in any transition, there are a lot of standard as well as legacy technologies fighting to become the choice of the majority of the people. The winner would be the connectivity of choice by nearly 50 or maybe 60 billion devices. So now let's see what are the standard wireless access technologies which are being used in IoT. There are plenty of devices that use these sort of standard wireless access technologies, including the smart home appliances, gaming consoles, video surveillance systems, e-health, fleet tracking, and there are so many applications. It's an obvious choice for providers and also for the consumers to continue using their current internet access, which they get through the Wi-Fi or any other cellular technology as the primary network option for their home appliances. So they do not need to change the internet connection when they use those appliances. As always, there is a catch. The power consumption of these devices is quite a thing. And most of these devices use some sort of static network access. And if you consider the routers and other smart TVs which you have at your homes, in most of the time, they are connected to the power. Or if you look at the LTE portable routers or access points, they are equipped with larger batteries. Another constraint in using the standard wireless access is that the data plan you usually obtain from your internet service provider or the network operator was designed for your mobile phone usage. So in this way, it's quite expensive if you are thinking in multiple devices per user. So if you need to go live or reach out a world mass market where direct internet access is required along with the consumer devices large enough to hold a battery or, as we mentioned earlier, or connected to a power outlet, then this is the choice of network which is widely deployed. The second type is private long-range technologies. The requirements of low power connectivity has opened a window to private companies to develop new networks with that specific constraints at the core networks or in their systems where you find some kind of a IoT flavor. So these private wireless networks are used for specific proprietary networks, and it's also to deploy some sort of network which allow third-party devices to connect and build a new ecosystem. The three leading technologies which fall into this particular category are the LoRaWAN, Zigbee, and sigfox. First one is the LoRaWAN. So LoRa stands for long range. So LoRaWAN means long range wide area network. So LoRaWAN is an alliance with an open approach. So as any other LoRa-based platforms use the LoRa curved spread spectrum, which is a what you call the radio modulation technology. In digital communications, the CSS or the chirp spread spectrum is a technique that uses wideband linear frequency modulated chirp pulses to encode information. So when you learn the data communication and digital communication subjects, you learn about the analog and digital modulation schemes. So this is a variant of such schemes. You can deploy the LoRaWAN network without paying any royalties to those equipment or the standard equipment manufacturers, but there's a small trick, or the only condition is that all the devices which are meant to be used in the LoRaWAN network need to have a LoRa chipset which is purchased by them. So it will not work with any other chipset. The next thing is the sigfox. So it has a different approach. So sigfox's approach is to provide a proprietary network instead of giving you or providing you some kind of an open network. So in this case, you can't build your own network. So the sigfox will provide the connectivity service for any device in your network at a small fee. So you have to pay whenever you use this technology to access devices in your network. So if you want to learn more on the sigfox technology, you can visit this particular site. It has a lot of information and white papers. So if you are interested about this sigfox technology, you can visit this site. And the third technology that comes under this category is the Zigbee. So Zigbee is an IEEE 802.15.4 based technology built on the physical layer and media access control defined under that particular standard. And it is intended for embedded applications which require low power consumption and also which tolerate low data rates. If it requires higher data rates, then Zigbee will not be a better technology. And also it is simpler compared to the LoRaWAN and sigfox and less expensive than Bluetooth or general wireless networks such as Wi-Fi. The main drawback of Zigbee is that it is mainly installed as a short-range radio connectivity, unlike the LoRaWAN and sigfox. And on the other hand, it is not as widely adapted by the equipment manufacturers worldwide compared to the other technologies. So when you're using any device which is equipped with the Zigbee access technology, sometimes you may find difficulties to find the compatible devices. So let's move on to the mobile IoT technologies, the third category. So this is the response to the proprietary low power technologies by the 3GPP or the third generation partnership project. As I remember, one of the previous sessions, Anuradha described what is 3GPP. So they are making the standards and they are IoT centered flavors of the LTE standard, which provides longer battery life, better coverage for IoT devices which are kept inside of buildings or underground, and smaller modular size, and it will reduce the cost of these devices as well. And the leading technologies of the mobile IoT are the NB-IoT or the narrowband IoT, the LTM, long-term evolution for machines, and finally, the extended coverage GSM IoT. So out of these three technologies, today we will focus only on NB-IoT and LTM. So as per GSMA or the GSM Association, we will discuss what is GSMA later. So in fact, the GSMA is an organization that represents the interest of mobile network operators worldwide. So the narrowband or the NB-IoT is a standard developed by the 3GPP, and it is based on low power wide area technology developed to enable a wide range of new IoT devices and services. So this slide shows some of the main features of NB-IoT. NB-IoT significantly improves the power consumption of user devices and also the system capacity and spectral efficiency. especially in the deep coverage, indoors and the undergrounds. And compared to the other standard technologies, it ensures a battery life of more than 10 years. And that will be an advantage for devices uh, which we are currently using in wide range of use cases. And new physical layer signals and channels are designed to meet the demanding requirement of the extended coverage in both rural and deep indoors. And ultra-low device complexity will ensure that the cost of device is minimized. So the initial cost of the NB IoT modules is expected to be comparable to the GSM or the GPRS devices currently we have in the market. So the underlying technology is, however, much simpler than today's GSM or the GPRS devices, and its cost is decreasing day by day. So when this technology matures, when it achieves the economies of scale, the price of a single unit will reduce. And it is supported by all major mobile equipment manufacturers and chipset and module manufacturers. So the NB IoT can coexist with the existing 2G, 3G, 4G, or 4.5G mobile networks. It also benefited from all the six. Hello, can you hear me?
Yes, sir.
There is an echo, I think.
Yes, a little bit of echo.
Okay. So it also benefited from all the security and privacy features of the existing mobile networks. And it supports the user identity confidentiality, entity authentication, data integrity, and also the mobile equipment identification, which we saw from the second generation mobile systems as well. So the next technology is the LTE-M, or it is the simplified industry term for LTE MTC. MTC stands for machine type communication. So when you learn the 5G techniques, you will learn three main things related to 5G technologies. One of the main concerns in 5G era is the connected world, where you will have to connect billions of devices using the cellular technologies. So one of the key aspects of 5G is massive machine type communication. So LTE-M is a version which comes in between the standard LTE and the 5G techniques. So it is also a low power wide area technology standard published by the 3GPP, as I remember in their release 13 specification. It specifically refers to a technology which is suitable for IoT. So as the name suggests, LTE-M is a low power wide area technology which supports IoT through lower device complexity as NB-IoT, and it provides extended coverage while allowing the reuse of installed LTE bases. This allows battery lifetime as long as 10 years or more for a wide range of use cases. And with the modem cost reduced to 20 to 25% of the current GPRS or the H modems, this is also a better contender in the IoT era. And this is also supported by all major mobile equipment, chip and module manufacturers worldwide. And it can also coexist with the current cellular networks. So this slide shows 4 of the key aspects of LTE. So it supports the voice, and it also have some sort of extended range and a deep penetration. And power consumption is also pretty much low. And most importantly, it provides the inter and intra frequency handover, which will enhance the mobility aspect. If you compare NB-IoT together with LTE-M, you'll see that the NB-IoT, as the name says, has a narrow bandwidth compared to LTE-M. So as a result, the peak data rates of LTE-M is higher than NB-IoT. And if you consider the latency of LTE-M is quite low compared to NB-IoT, but battery life of narrowband IoT is higher than LTE-M. And power consumption, the NB-IoT is good for the low data rates, and LTE-M is good for medium data rates. And the cost per module, NB-IoT is lower. And since the bandwidth is low, in NB-IoT, you can use the in-band as well as guard band frequencies of LTE range. And in LTE-M, you cannot use the guard band for data transfer. And the penetration in indoors is excellent in NB-IoT, and LTE-M, it's better than the standard LTE. And only the LTE-M is supporting the voice over LTE. That is the requirement of sending voice data through your available bandwidth. Now, we talked about the GSMA, the GSM Association. Now, you might be thinking that what is the difference between the GSM technology and this particular association? So in this context, the GSM stands for this particular set of words, which is written in French. I don't know the exact pronunciation of this word. It sounds like Group Special Mobile. And in fact, it was formed in 1982. In the GSM technology, we call it as the Global System for Mobile Communication. But in this case, it's Group Special Mobile or something like that. So the GSMA represents the interest of mobile operators worldwide, and they do not make standards, but what they do is they showcase how these standards can be used at the industry. At the moment, they are uniting more than 750 operators with almost 400 companies. And the membership includes the handset and device makers, software companies, equipment providers, internet companies, and also the organizations in the adjacent industry sectors. So if you are interested in the GSMA, please visit their site. There are a huge amount of information and other technical details available related to the technologies which they have promoted in the industries. Those can be varying from the cellular technologies to the technologies which you can use at your homes as well. And that's it for the first session. I will hand this session over to my colleague Anuradha to continue on the second session.
Thanks, Rajiv, and I hope you can hear my voice clearly.
Yes, Anuradha.
Okay. All right. So I think this is kind of going to be a world record because I'm going to cover these three topics within half an hour. I haven't tried this before. SDN for IoT, cloud and IoT, and IoT security. The three topics themselves are, as probably you can understand, they are the content involved in these three different areas are very large, but let me try to give you at least a very high level understanding of these three particular segments relevant to IoT, because the understanding of these areas is also important in terms of understanding IoT as a whole. So the first one is, what is the relationship between IoT and SDN? SDN stands for Software Defined Networking. The definition, how ONF, or the Open Networking Foundation, defines SDN is the classical definition of SDN, the physical separation of the network control plane from the forwarding or the data plane, where the control plane can actually control multiple forwarding planes. So that's the classical definition of SDN. So because of that, you have three layers. I think we understood the meaning of layers also in different IoT stacks as well. Infrastructure layer, control layer, and application layer at the top. So application layer in the classical SDN definition could be any application, business application included. And then you have SDN control software, which is part of the SDN layer. And it has different network services. And then you have network devices at the infrastructure layer, which are not having control, the conventional control plane. And how do you communicate between different layers? I think that is also something we discussed as part of IoT. One mechanism, or the obvious mechanism that we use today, is the usage of APIs, application programming interfaces. For example, between the control layer and the application layer. And then you have control and data plane interface, the ancient or the most common being open flow. So this is the classical definition of SDN. So if you really need to understand what is SDN and how SDN works, I suggest that you actually go and check our videos on RTube, which has a series of videos explaining not only SDN, but NFV, cloud, and the whole telco softwareization type of content. But the salient features of SDN, which also helps in terms of bringing in IoT also to the context of SDN, the ability of an SDN, which is a software-defined network, be directly programmed. And it is also agile, meaning that it can actually withstand the changes and also flexible in terms of the changes in the network. And of course, it is centrally managed because you sort of abstract the control or the control to a central location. And it is programmatically controlled. So you, instead of the word configuration, we conventionally use in networking. Instead of configuration, we now use the word programming. So we basically say we are programming a network instead of configuring multiple network elements. And also it is based on open standards, and as a definition and as a foundation, SDN is vendor neutral, but we have not only SDN, but these days, pretty much anything could become vendor proprietary based on different implementations. But how you really sort of relate IoT to SDN is through something called SD-WAN, because SDN basically, if you check the videos, you will understand SDN is one of the ways that you can implement software-defined something. We say SDX, software-defined anything, and SDN is where you implement software-defining in the context of networking. But you can apply software defined in wide area networking. You can apply that in data centers pretty much anywhere in the context of ICTs and telecommunication. So software defined WAN is an area where you actually apply the same principles of SDN in the case of wide area networking, basically providing services to enterprises, where it allows you to not just have private connections for inter-branch or inter-location connectivity, but gives you the ability to use internet as a private network, because we know internet is not a private network, it's a public network. Internet uses public IP addresses, and we know that is also not a safe place to send your data. With SD-WAN, you can sort of create end-to-end encrypted tunnels. You use Ethernet pretty much like a connection to tunnel your data. And so you can combine the internet-based tunnel with your private IP, VPN, MPLS-based connectivity as well. So that gives two advantages to the enterprise. One is that it actually brings down the cost of private connectivity, and also it gives redundancy, because now you have a separate path you want through not only one, but through multiple ISPs if you want, to have redundancy for the enterprise connectivity. SD-WAN has multiple components. The two main components being the SD-WAN edge, where the central intelligence at a branch location, where you connect all the multiple WAN connections. It could be a private connection to the WAN edge. Of course, you have your own network terminating units in front of the SD-WAN edge. So SD-WAN sits, the edge sits behind the multiple WAN connections. And then you have an SD-WAN controller, where it could be somewhere in a data center, in a public cloud or private cloud. And irrespective of the location of the SD-WAN edge, it has the ability to sort of see the total view of the network. It could be, one location could be in US, one location could be in Europe, another location could be even in Sri Lanka. But the controller has the ability to see the total picture of the network, and it also has the ability to centrally control, or in SDN terms, centrally program the entire network the way that the enterprise would want the network to behave. And also we have multiple other things that we can connect to public cloud and all sort of things. So how do you bring in SDN to IoT? Actually is through SD-WAN, where the capabilities of managing IoT devices and IoT workflows or IoT type data can be combined into the SD-WAN edge, or else you can have a separate SD-WAN edge in front of the SD-WAN edge. Sorry, in front of the IoT gateway. So that means IoT gateway can be inbuilt to the SD-WAN edge, or it could be sit in front of the IoT gateway. So that is how you sort of combine IoT with the SDN, but it is actually with SD-WAN. Now, when you do this, because most of the IoT applications, you know that we actually use an IoT gateway, because suppose you have so many IoT devices in your factory or in your location of business, you don't want them to be directly connected to a network on their own or through individual connections. Instead, what we usually do, the industry practice, is that you use a gateway and connect all these multiple devices to the gateway first, and then the gateway connects it to the whatever the cloud or the management intelligence location. So this SD-WAN edge, if it is combined or otherwise, can actually provide multiple features, like it can manage multiple devices, multiple IoT things, and provide customized way of allocating network resources. For example, allocating bandwidth, things like that can be done. And more importantly, those things can be centrally controlled through an SD-WAN control and service orchestrator. So that is how you relate IoT with SDN. And if you look at the big picture, we never talk about running an IoT thing or IoT device and that being controlled directly by an SDN controller. Instead, what normally we do is that actually we control the SDN, the IoT gateway, and then through the IoT gateway, we provide the required services to the IoT devices. It could be providing an end-to-end, so for example, in 5G terms, providing an end-to-end network slice, for example, for one particular IoT application, let's say something like robo-arm doing manufacturing in a manufacturing site. Last mile connected through 5G, and all the IoT related things, and what Rajiv just mentioned, the connectivity access technologies, all that is there in the access. But when it comes to the network and network transport, then you use SDN, but some flavor of IoT intelligence, not just doing classical SDN, which you will anyway do in an SDN network, but apply the elements of SDN intelligence to that SDN control management, so that you manage the network layer, network elements, and you have the understanding, you being the SDN controller, it has the understanding of what sort of traffic that network element actually handles. In this case, it's your IoT traffic. So that's at very high level, the SDN relationship to IoT. Let's look at IoT and cloud. So cloud and IoT, I think individually, if you, I think we discussed those things individually as well. So IoT is basically in the context of cloud computing and also the cloud itself. IoT is the source of data. So we have all these IoT sensors, which actually collects data from the field or whatever the IoT environment. And the big data approach is actually the analytic part of that collected data. It doesn't have to be big data, but usually these days, when you're talking about, especially what Rajiv mentioned about massive machine type communication in 5G, we are expecting the number of devices to be in the terms of billions. So when the number of devices are that big, of course, the collected amount of data is also the variety, the volume, and the velocity, everything, all the V's associated with big data is actually coming into the picture. So the big data part is the analytic part of that collected data of the IoT devices. And where cloud comes is actually, basically, it is the location of that collected data, whether it is raw data or the process data with some business intelligence or without. It's a location of your storage of data. And it has the ability also to do some sort of processing. For example, if you take analytics, that can also be done in the cloud. So basically, if you, in the context of cloud, and if you try to understand IoT in the context of cloud, you can basically see On one side, you have your IoT devices connected to some sort of a network, which includes the network that Rajiv just mentioned. And then REST, collecting, or rather collected data and data processing and all the analysis, analytics, everything is the part where the cloud handles. So basically you have IoT devices, communication network, and the cloud. So if you want to look at it that way. So if you think what is an IoT cloud? So as I just mentioned, it is it gives the cloud type of capability where cloud has all these capabilities of elasticity. You can scale up, scale down, scale out, scaling, and also you can incrementally increase the capacities and resources the way you want. And also it has this massive ability to sort of use virtualization and share resources using techniques like statistical multiplexing and things like that, so that you can have a large resource pool of computing power, storage, memory, and CPU cycles. And also you have these hypervisors and virtualization techniques. So you have the best use of your resources or the assets using cloud technologies. So the cloud can actually be the single infrastructure, if you will, like it hosts your data, it does your processing, analytics, reporting, storage, servers, everything. So that is the IoT cloud. Why do you need IoT cloud? Is because like everything is going to the cloud these days. So if you want, you can have this capability of IoT cloud, which gives you the efficiency, flexibility, scalability, not because of your using it for IoT, but it's because the cloud itself, the definition or the purpose of cloud is actually have that efficiency and flexibility. So when you have your data and the processing analytics hosted in an environment, efficient, flexible, scalable, and all sort of these cloud and cloud native capabilities, it actually gives you massive advantage in terms of handling your data. So a few examples, I'm actually not endorsing any of these cloud players. There are more cloud players, but these are the ones actually comes to our mind when you talk about cloud: Amazon Web Services, Microsoft Azure, and GCP. We also have Oracle Cloud, IBM Cloud, VMware Cloud, Tencent, and Alibaba Cloud, and multiple other clouds these days. So, for example, if you take Google Cloud, I hope many of you have at least seen how Google implements their cloud infrastructure. In the context of IoT, again, you have the sensors, which are actually sensing your things in the context of IoT and collects a lot of data and also receives a lot of control signals. As I told you earlier, the cloud, this being a public cloud, it doesn't have to be a public cloud. You can implement all these features in a private cloud and still do the same things that Google Cloud does. But these guys, Google, they are doing it pretty much in a very easy and flexible way that you can pretty much anybody who wants to experiment with IoT can use the readily available features. For example, if you want to analyze data, if you want to do queries and AI platforms, API management, data flows, etc., everything is pretty much available as packages. Only thing you have to pay. But so that's something we also talked about earlier, because we really don't have to reinvent the wheel. If these good capabilities are available, we can reuse them in our IoT projects as well. Now, the last piece in today's discussion, I think we have time for that discussion as well, is about security. Now, security itself is a very timely, very important, very crucial topic, not only to ICT and IoT, but for pretty much anything these days. So it's not just security. When you say security, we know that we usually think about the technology aspect in the context of ICT and telecoms. But security is actually directly related to privacy these days, because we're not talking about autonomous, like self-sustained, self-healing type of robot type of devices. We are talking about devices which are deployed in the field or the environment by humans for the use of the humans. It's not the case that these devices by themselves go and sort of plant themselves in the field and start working. Some say that is the sort of future that we are actually heading in, but let's hope that is not the case, because we never want the devices to control us. Instead, we want us to control the devices. So because there's a people or the human involvement in IoT and also in ICT, we're talking about privacy and a lot of private information. Now, one thing why this, for example, WhatsApp privacy issue came to surface those days, and we have a couple of videos on that as well in our ArcTube channel, is privacy is pretty much a serious issue these days. If you take the European Union's GDPR or any other privacy, but in this part of the world, I don't think in Sri Lanka, we really that much concern about privacy of our private data. But you have to really look at, it's not just security that you're going to assure in IoT environment, but you have to make sure that it is actually, you're protecting the privacy of basically the collected information of related to people. And with that comes the trust. So it's not just security. You cannot actually discuss about security alone. You have to talk about security with privacy and together with trust, right? So security basically side of the issue where you're trying to achieve the confidentiality, availability, and integrity. That is the core definition of security. But with privacy, you are talking about the personal information. You're not basically talking about the privacy of a physical device, right? We never care. I mean, we don't care about the devices because we say they are sort of unconscious elements, right? We say we are conscious. But in the case of IoT, because of this involvement of the human or the people factor, you have to make sure that you support the anonymity of collected data and how the collected data is stored, processed, and are you actually crossing the international or the territorial boundaries of one jurisdiction to another jurisdiction. So these things matter. And with that, you have this, you have to have some sort of an assurance where you can be assured that, or confidence that the people, data, and devices will actually function the way that you expected them to behave. You want your security, you want your privacy, your devices, everything to behave the way that you intended them to behave at the first place. So that is where how trust comes in. Then you have multiple organizations, basically IoT Security Foundation and also ITU, trying to come out with globally accepted or globally acceptable frameworks and standards, some sort of guidelines where they're trying to help the large ecosystem of IoT to implement these security concerns. So one such document is IoT Security Compliance Framework by IoT SF or IoT Security Foundation. They're trying to secure and trying to come out with clear best practices in appropriate security, because IoT security is a very, it's a very open field where you cannot just say that it's not like 3GPP release 15 standard, which basically defines how that particular standard should work, but rather IoT security compliances, if somebody does not implement that, I mean, there's nothing we can do, because everything else will work until there's a security breach, right? So these are basically called best practices. And if you go and check the ITUT recommendations, as we discussed, I think in one of the previous sessions, we have these multiple ways that ITU classifies their series. We have one called X series about data networks, open system intercommunication and security. Within that, we have a range of standards from X.1300 to X.1499, which are for security applications and services, secure applications and services. Within that, from X.1360 to 1369, we have Internet of Things security. So you have like 5-6 standards specifically for IoT security. So one framework by IoT X.1361 is about a security framework for IoT based on gateway model. One reason why even the previous organization, which is IoT Security Foundation, looking at the model where IoT security is defined, using a gateway as a centerpiece. Because if you don't have that type of thinking, then your security area becomes quite large, because we're talking about billions of devices. And if you are to ensure the security of all these devices and to lay out a framework where every single device is actually taken care of, I think that is something, at least of today, it's something that it's kind of difficult to achieve. Because of that, we are trying to sort of use a gateway, because you know that behind the gateway you have your IoT devices, and let's try to build a sort of a framework surrounding the gateways and components inside the transport network and other networks. So I sort of request you to go and check for yourself what is, because there are no diagrams in this one. It's a list of recommendations provided by ITUT, how to implement security. And then when it comes to privacy issue, we have this PII, which is personally identifiable information. Now, if you take an individual these days, you have pretty much, there are a lot of personally identifiable information, like your face, your iris, your fingerprints, your thumb prints, or your palm prints, maybe several other things which are personally identifiable information regarding the human body, or you have your NIC number, your passport number, your social security number, those things. The moment you have an associated IoT device, these days most of you you're using a mobile device. You are wearing one or two wristband-based devices like your health meters, your alarm clocks, I don't know, the watches, the computing and mobile phone inbuilt phones, several other things, right? So these devices actually collect a lot of your personal information, like maybe like your medical information, maybe your whereabouts, your tracking details. If it is, for example, your let's say you are an IoT-based refrigerator, which automatically sort of makes orders if the resources inside the refrigerator, for example, the number of eggs goes down from 5 to 10 to 5, it automatically orders eggs. So your consumption patterns is also kind of personal information. So how do you make sure that you actually address this aspect of PII or personally identifiable information in the context of IoT? You have two associated standards. One is about information technology security techniques, code of practice for personally identifiable information protection. I'm not going to discuss that. You can have a look. And these are like addressed by both ISO standards and also ITUT recommendations. And then we have information technology security techniques for privacy framework. So in the context of IoT and personally identifiable information, you can think of two scenarios how IoT is provided as a service. In figure 1, I got this from X1363 standard. If a single service provider is providing the service, it is basically you have the devices, single service provider collects the data and stores the data and do some, maybe doing some processing, and through an application provides services to the user. So if they use the internet as your mode of communication. So the entire stack, collecting, processing, storing, and application is actually managed by one single service provider. There could be scenarios where multiple service providers provide the service to the end customer. You have the devices, one service provider collects and stores data, but the IoT applications, the business intelligence is actually provided by maybe two other companies or two other service providers. So you have multiple APIs implemented between these service providers, application programming interfaces, and this provider A makes available the data to other organizations to use and provide information to the end customer. So whether it is model 1, single service provider, or multiple service provider, the basic idea is actually to follow this framework in terms of handling PII. First, the service, because when you say about personally identifiable information or the privacy of our own data, the most, the controlling power is with the user. I mean, if you take, for example, WhatsApp privacy, again, as an example, they cannot just enable what they want. They have to ask the end user, which is the WhatsApp customer, these are the changes that we are going to, we are proposing to you that we are planning to implement. If you like, you can agree. If you don't like, you don't have to agree, right? So the user himself or herself has the ultimate decision of making sure that how these systems, whether it's IoT device or a thing or a communication network or the cloud where your data resides, you have the power. I mean, ideally, you have the power to decide what's going to happen to your data. So the model says the configuration of own PII preferences. Basically, you have a ACT, which is an access control table. You can go and update through a web API or an application. You can go and update how it should be behaved. And then that information is actually fed to your IoT devices, storage, and applications to the entire stack of IoT side. So at the time of collecting data also, your privacy is preserved. At the time of storing, processing, again, what you dictate as your privacy terms is also preserved. And also as an application, when you consume the collected data, again, your privacy is actually protected. Now, if you look at why security is important, like everything else also important, like SDN is important, cloud is important, I think, but security is more important. Now, I think you have heard about bots, right? Not the robots, but the bots in the internet, where anybody can sort of use your device which is connected to the internet. Those days it was just your laptop or the computer or the mobile phone, but you have pretty much like 10, 15 devices which could be connected to the internet, like your wristwatch and maybe multiple other devices that you carry or that things surround you. So that gives, for example, if you want to give a sort of a botnet type of an attack, you have so many bots, right? Not mobile phones and computers, but all these small devices can actually generate a lot of attack traffic to a single target location. Now, OWASP, or Open Web Application Security Project, they actually, every year they come out with IoT top 10 type of security issues. Now, this is the 2018 issue. Now, if you look at these are very shocking findings in terms of IoT security. First one being the weak and guessable passwords. I think that is something not only applicable to IoT, but it is applicable to pretty much anything connected to not only internet, but connected to any network these days. The password security is something that everybody talks about. And then insecure network services, the security problems in the network, insecure ecosystem interfaces, lack of security updates. Even if you take a mobile phone or a PC or a laptop, so many security updates need to be done in terms of operating system, in terms of virus guard, or whatever the security mechanisms that you implement. Then outdated components, both hardware components, firmware components, and software components. And then inefficient privacy protection, insecure data transfer, where things really need to be encrypted. If it is not encrypted, then you are making available for the people to sort of come and look at the unencrypted data. And then lack of device management. You just plant an IoT device and you really don't have track of that device. And if you really don't know your IoT devices, how many devices I have, where those devices, what is the health of these devices, of course, then you have a very large security risk. And default settings, I think most of the default settings, for example, by default, most of the IoT devices security is disabled, right? So you have to, I think, go and enable that and then set what sort of security that you want to set, right? So if you are doing an IoT project, you can do an IoT project just for IoT security if you want, because that is a very important aspect even today and also in the future. And also lack of physical hardening. These are some of the areas of security applies. I'm not going to discuss, but just want to show you that every layer of the stack, whether it is the application, cloud, network communication, your gateways, including your SD-WAN gateways, then your sensors and actuators, and finally your devices and data types. Everywhere you have a potential security weakness or risk. If you have, then it doesn't matter if you have the best cloud platform, best communication, but you have your sensors are insecure, you make your entire chain insecure. So it's a famous saying that you are secure, your security is the security of the weakest link of the chain, right? So this is from Kaspersky, one of the leading security organizations, directly from one of their slide decks, where security vulnerabilities in an IoT ecosystem, where can we find these security vulnerabilities? Pretty much everywhere. Like if you take sensors, your controls, your communication links, the ones that I just mentioned, right? So in a pictorial format, then in the cloud, these vulnerability can be exposed by the bad guys to run a botnet or come through a backdoor, do privacy violation, collects privacy information and leak privacy information, data theft, spying, and so many things. Now, attack scenarios also could be like you can intercept the communication link. You could use man in the middle attack and use impersonation, plant backdoors and buffer overflows, DDoS attacks, all these things which are pretty much possible with any IP network, especially any network connected to the internet, is actually possible with a lot of volume, because we're talking about billions of the devices. So it's not just these personal computers, laptops, and mobile phones. If the threat landscape is this much for that, when you include IoT, your threat landscape, actually, the threat surface becomes quite large, because it actually inviting the bad guys to come and do bad things at multiple places, starting from the very bottom of the stack, from the device, sensors, actuators, communication links, access networks, cloud storage, cloud processing, applications, APIs. So pretty much everywhere that you can sort of find for a fault or a vulnerability. So finally, if you, for example, the central piece in most of the networks, IoT gateway, this is again from Kaspersky, gives an example where the red arrows are showing the work of the bad guys, whereas the intended legitimate traffic flows are shown by the white links. So it could be multiple places, like directly targeting the gateway communication and targeting the cloud and targeting the other devices, which is coming from the application side. And some of the suggestions, not just by Kaspersky, but in general, are the ones that we talked about earlier as well. So if you are running an operating system, secure the operating system and sort of use vulnerability detection, vulnerability scanning at least. There are a lot of tools to be used in vulnerability scanning. And like we use in like white label hacking, white collar hacking for enterprise network health checks, we have to do similar health checks for IoT networks and IoT devices, just to make sure that these devices are actually used for the purpose which was originally intended at the time we actually deploy these devices. So some security tips before we wind up for today. We have to enable the security features. Usually they are, by default, their security is turned off. And you have to switch it on if it is disabled. And if possible, use a separate Wi-Fi network or use a separate SSID if possible, with password protection to connect if you are connecting using Wi-Fi as your access technology. And if you are using any other access technology like Rajiv mentioned, Zigbee or anything else, you have to apply the same measures to make sure that your IoT devices are actually separated from the rest of the devices being used. And not use default or weak passwords like ABC123, and use two or multi-factor authentication. I think pretty much any web-based application these days request you to have two or multi-factor authentication, one-time password over the top, use to SMS-based two-factor authentication, software-based, hardware-based, token-based. Anything has to be implemented to make sure these authentication and security, because as Rajiv mentioned, some of the battery capabilities of IoT devices can last for, let's say, 10 or more years, which means that we actually intend these devices to actually work at remote places where we never intend to go and visit, go and look the device. Only way that you can track that device is through the data that we collect. And you have to make sure that device, which is not usually accessible for a period of, let's say, 10 years, is having the right security measures just to make sure that it is secure. And you have to check what are the security features available across the stack, starting from the very IoT device, your sensors, actuators, the communication links, the APIs, interfaces, virtual interfaces, physical interfaces, and cloud, the storage, processing engines, analytics engines, and also the end applications, the APIs, and also the type of security that you use for the application side. And if possible, try to switch off the IoT device not in use. I think that is the best security that we have in the world, right? If you want to protect your computer from hackers, switch it off, right? It doesn't make sense, actually, if you are to work, operate the network and try to do your day-to-day business, but you cannot switch it off. But when you're not using it, if you can switch it off, and it's very safe, right? So that is why I have listed that as the last step. So with that, I think we have come to the end of another session. Thank you very much. If you have any questions, I think, Rajiv, we can take a couple of questions.
It's time for the Q&A session now. Feel free to type in your questions in the Zoom chat. And I would also like to mention that we have put up the link to the feedback form. Make sure to fill it today as well as in the next week to receive your certificate of participation. And keep in mind that only those who fill the feedback form in all 5 sessions will receive this certificate. And make sure to provide the name you want in your certificate in block letters, preferably your full name.
So any questions? Yes, Primash is asking, is edge computing is the solution for security threats? Security threats, I think there are multiple solutions. I think if you can remind the last slide I showed you, you have to address security not only at the edge, right? Because edge computing is taking your whatever you have in the cloud closer to the IoT network, but that only shifts the location of your data from processing and location of your data from the remotest or the most remote data center to if you want a small data center which is closer to the edge connected IoT devices. So that actually gives you some sort of manageability, because rather than having your data and processing at some distance location, now you have edge computing location where you have like a shorter distance to the edge computing. So you can sort of, in terms of management, it is much easier. But then it actually also makes it some sort of a distributed environment. If you have a control and all these intelligence, collected data, processing, analytics in one single cloud, but if you want to have edge, that means you're actually distributing that intelligence. So that distribution itself actually makes 2 things. One thing is that if it is central, if it is attacked, then everything is gone. The other thing is that if it is distributed, if one place is attacked, everything else is, if it is not attacked, everything else is safe. Only that place attacked is actually down. But the other side is that once distributed, you're actually increasing your attack surface. So you're making available multiple small data centers and pieces of data, exposing yourself. So you have to actually balance it out, see what sort of information should come at the edge location, what should come at the regional data center location, what should go to the core data center, or if you want, if you're putting anything to the public cloud, what sort of data should go to the public cloud. And most importantly, security is not only one location. As I always say, security needs to be implemented across the stack. If you can remember the IoT definition and IoT framework, we have all these layers, and on the either side, we have the management layer and the security layer. So this security layer goes from very bottom to very top. That is from the IoT device itself to the top application. So security needs to be implemented everywhere. I hope I have answered.
Yeah, Anuradha, I'll add something. In fact, edge computing will be the solution for the latency effect. So if you do the whole processing at the cloud, then it will take a lot of time, and also you will need a huge core network bandwidth to send the gathered data to the cloud. So what the edge computing does is it processes the data at the edge so that the burden on the core network and other carriers will be reduced, and also the response time at the level of actuators will also be reduced.
Yes. Anything else? You're welcome, Primash, I'm sorry.
So if you have any more questions, if you can't ask it here, please write to us. I think all of you have our emails. Or if you can send it to a coordinator here, Isuri. So she or Hansika might send those questions to us. So we can respond to you privately if you want, if you can't ask it here.
So looks like that's all the questions for today. And this marks the end of today's session. Thank you, Mr. Weragama and Mr. Udunuwara, for spending your valuable time. And thank you everyone for joining with us. And we hope to see each and every one of you in the final session next week. Thank you and have a good night.
Thank you. Good night.